In October 1970, a U.S. Navy C-121 Constellation aircraft was preparing to land at McMurdo Station in Antarctica. The weather was extremely severe, and the pilot couldn't see anything ahead. Even so, he remained confident because the compass in the cockpit was pointing him in the exact direction that air traffic control had instructed him to follow. But when the runway failed to appear, McMurdo Station informed the pilot that he was actually flying in the wrong direction. After several unsuccessful attempts to locate the runway, the aircraft eventually ran low on fuel, forcing the crew to make an emergency landing on a random stretch of terrain. Fortunately, no one was injured in the incident. But here's the real question. If the pilot was following the exact heading given by air traffic control using his compass, how did he end up flying in the wrong direction? It was later discovered that neither the aircraft's compass was malfunctioning, nor had air traffic control given incorrect instructions. The real reason was a third force, one that no human can control. Instead of trying to fight this invisible force, aviation experts have learned to work with it, and one of its biggest secrets is hidden in the numbers painted on airport runways. Welcome back to another video from Nova Reports. If we look at a satellite image, this runway at Dubai International Airport is labeled 30L. But what exactly does the number 30 mean? Not just in Dubai. If you look at any airport anywhere in the world, you'll notice that runway numbers always range between 1 and 36. Runway numbers aren't just random markings. Behind them lies a fascinating system that tells pilots a great deal of important information. Whenever an airplane takes off or lands, the pilot's primary objective is to make the maneuver as smooth as possible. Not only is that essential for passenger safety, but it's also better for the airline. To achieve a smooth takeoff and landing, pilots always prefer to operate the aircraft into the wind. This wind blowing directly toward the aircraft is known as a headwind. Here's why. An airplane can only take off once enough airspeed is flowing over its wings. That required airflow can be created in only two ways. Either the natural wind is already blowing at a high speed, or the aircraft accelerates forward using its engines. Take the Airbus A380, the world's largest passenger aircraft. It cannot become airborne until it reaches roughly 240 to 295 kilometers per hour. In other words, if the aircraft is rolling down the runway at 240 kilometers per hour, then its wings are also experiencing 240 kilometers per hour of airflow. But if there's a 40 kilometers per hour headwind, the aircraft only needs to accelerate to 200 kilometers per hour to generate the same 240 kilometers per hour of airflow over the wings. The airplane is moving at 200 kilometers per hour, while the wind contributes another 40 kilometers per hour from the opposite direction. That brings the total airspeed over the wings to 240 kilometers per hour. As a result, the aircraft lifts off several seconds sooner, using less engine power. The same principle applies during landing. When a headwind is present, the airplane's speed, relative to the ground, known as ground speed, is reduced, allowing for a much smoother landing. But if there is no headwind, the aircraft approaches the runway at a much higher ground speed. Not only does the touchdown become much harsher, but the pilot must also rely heavily on braking, wing flaps, and reverse engine thrust to bring the aircraft to a stop before the runway ends. That isn't ideal for safety, and it also causes greater wear on the tires and engines. Since headwinds are so important for both takeoffs and landings, airports are designed so their runways align with the prevailing wind direction. In most parts of the world, the wind generally blows from only two primary directions throughout the year, one during the summer and another during the winter. For example, in Dubai, the wind usually comes from either the northwest or the southeast. That's why the runways are aligned in exactly those directions. If the wind is blowing from the northwest, aircraft approach over the desert side to land and then take off toward the Arabian Gulf. If the wind shifts and starts blowing from the southeast, the operation is reversed. Aircraft approach from the Arabian Gulf side for landing and depart toward the desert. Now let's continue using Dubai International Airport as our example. If we place a compass over the airport from above, 0 degrees points north, 90 degrees points east, 180 degrees points south, 270 degrees points west, and 360 degrees brings us back to north again. You'll notice that if we start at 0 degrees and rotate all the way around to 300 degrees, that direction lines up perfectly with the runway. So, if an aircraft is approaching from the desert side and reaches a specific waypoint before turning to a heading of 300 degrees, it will fly directly onto the runway. In aviation terminology, 300 is simply referred to as runway 30. The letter L stands for left, while R stands for right, because Dubai International Airport has 2 parallel runways. But if the wind is blowing from the desert toward the Arabian Gulf, aircraft must approach from the Gulf side instead. If you look at that end of the runway, you won't see 30 painted there. Instead, you'll see 12 and 12R. That's because from the Arabian Gulf side, the runway is aligned with a heading of 120 degrees. So, in reality, there are still only 2 runways. But when viewed from the desert side, they're designated 30. When approached from the Gulf side, the exact same runways become 12. No matter which runway you look at, anywhere in the world, if you subtract the smaller runway number from the larger one, the difference will always be 18. That's because 18 represents 180 degrees, and a runway is simply one straight line with 2 opposite directions that are exactly 180 degrees apart. Here, there are 2 parallel runways. That means the wind generally blows from only 2 main directions, either from the Arabian Gulf or from the desert. But what happens at airports where the wind can come from all 4 directions? How do aircraft land there? To answer that, let's travel to Mumbai International Airport, where you'll find 2 intersecting runways. If the wind is blowing from the east, aircraft use runway 09 for both takeoff and landing. The number 09 represents a magnetic heading of 90 degrees. Because writing only 9 could create confusion, a leading 0 is added to make it clear that it represents 90 degrees. Now, what would the runway number be at the opposite end? It's simple. Just add 18 to 9, giving you 27. If the wind is blowing from the west, aircraft approach along a heading of 270 degrees, allowing them to line up perfectly with runway 27. Mumbai's geographical location is unique. Unlike many other regions, the wind doesn't blow from only 2 primary directions throughout the year. During certain seasons, takeoffs and landings shift to the second runway, the one that intersects the first. That runway is designated 32 on one end and 14 on the other. So far, we've learned that runway numbers are far from random. They actually represent a runway's compass heading and indicate the direction pilots should fly when approaching it. To simplify it even further, if the wind is blowing from the northwest, Mumbai Air Traffic Control will assign runway 32 for landing. The aircraft will first fly to a designated waypoint, an imaginary point located over the Tansa Reservoir, directly in line with the runway. From there, the pilot turns the aircraft to a heading of 320 degrees, allowing it to line up perfectly with runway 32. At this point, you might be thinking that runway numbers are based on compass headings, and compass headings never change. So shouldn't runway numbers remain the same forever? Surprisingly, they don't. Let's travel to Kristiansand Airport in Norway. If we look at a satellite image from July 2025, we'll see that one end of the runway is marked 21, while the opposite end is marked 03. In other words, aircraft approaching from the north align with a heading of 210 degrees, while aircraft approaching from the Skagerrak Strait line up on a heading of 30 degrees. But if we go back just 10 years, we'll find the exact same runway. The only difference was its numbers. Back then, one end was marked 22, while the opposite end was labeled 04. That means the approach from the Skagerrak Strait, which is now aligned with 30 degrees, was previously aligned with 40 degrees. Why did that happen? Did airport management make a mistake? Was the compass inaccurate? Or was something else responsible? To understand the answer, we need to explore one of the most powerful forces affecting our planet: magnetic drift. Our planet isn't just a massive ball of rock and soil. Deep inside Earth's core lies molten iron that is constantly moving. As this liquid iron circulates, it generates an enormous magnetic field surrounding the entire planet. In other words, Earth behaves like one gigantic magnet floating in space. And like any magnet, Earth's magnetic field has both a north pole and a south pole. The thin needle inside a compass isn't just an ordinary piece of metal. It's actually a tiny magnet balanced on a delicate pivot. One of the most basic laws of physics tells us that opposite magnetic poles attract each other. Since the north-seeking end of a compass needle is itself a magnetic north pole, it naturally rotates toward the south pole of Earth's magnetic field. At this point, you might be wondering something. If the compass needle is the north pole of a magnet, then why is it attracted to Earth's north pole? Shouldn't two north poles repel each other? This is actually one of the most fascinating facts about our planet, something many people don't realize. The geographic North Pole, located near the Arctic, is actually the south magnetic pole of Earth's magnetic field. Likewise, the geographic South Pole, located in Antarctica, is actually Earth's north magnetic pole. We call the Arctic the North Pole simply because the north-seeking end of a compass points toward it. But magnetically speaking, it's actually Earth's south magnetic pole. The molten iron inside Earth's core, however, is not stationary. It slowly shifts and moves over time. As that liquid iron changes position, Earth's magnetic poles gradually drift as well. When scientists first measured the magnetic North Pole with precision, it was located near Canada. Today, it has been moving rapidly toward Russia. That's exactly why airports located near the poles experience noticeable changes in their magnetic headings every few years. As those headings shift, runway numbers eventually have to be updated, sometimes by a full degree at a time. The incident involving the U.S. Navy aircraft in 1970 was also the result of this same phenomenon: magnetic drift. Because Antarctica lies so close to the magnetic pole, compass readings there change much more rapidly. Aircraft also visit the region far less frequently. In this particular case, nearly 6 months had passed without any flights. During that time, the magnetic readings had shifted significantly, and no one realized just how much they had changed. In Canada, the situation became so frustrating that airport crews grew tired of repainting runway numbers every few years. Eventually, they came up with a solution that permanently solved the problem. Instead of aligning runways with magnetic north, they began referencing true north, which never changes. Earth's geographic North Pole, the one used by GPS and located in the Arctic Ocean north of Greenland, remains fixed. Canada has now aligned many of its runways using the GPS-based true north instead of the constantly shifting magnetic North Pole. The advantage is obvious. Runway numbers no longer need to be changed every few years. However, this approach also has one drawback. During landing, pilots can't rely solely on the cockpit compass. Instead, they must use GPS for navigation. In other words, the entire landing procedure depends on GPS satellites. Beyond the runway numbers, you'll also notice a variety of unusual white markings painted on the runway. Those markings communicate a tremendous amount of information to pilots as well. For example, at the beginning of every runway, you'll see a series of long white stripes that resemble the keys of a piano. In aviation, these are known as threshold markings. These markings allow pilots to judge the width of the runway from a considerable distance. If there are 4 stripes, the runway is 60 feet wide. If there are 8 stripes, it's 100 feet wide. And if there are 16 stripes, like those found on some of the world's largest runways, the runway is a full 200 feet wide. At Dubai International Airport, immediately after these 16 threshold stripes, you'll notice 2 sets of 6 white bars. These are known as distance markers. The first set of 6 bars indicates that 500 feet of runway has already passed. The second set tells the pilot that 1,000 feet have passed. Next come the 2 large white rectangles known as the aiming point markers. As the aircraft approaches at nearly 300 kilometers per hour, the pilot aims the airplane so that its touchdown point is locked precisely onto these 2 markings. That's because this is the strongest and safest section of the runway, designed to handle the aircraft's initial touchdown. Beyond the aiming point markers, you'll see another set of 4 white stripes, followed by a set of 2. These also help pilots judge how much runway has already passed beneath them. If the aircraft still hasn't touched down by the time it reaches the final pair of stripes, it means the landing has gone too far down the runway. Even if the wheels do touch the ground at that point, there may not be enough runway remaining to bring the aircraft to a safe stop. In that situation, pilots apply full engine thrust and climb back into the air. In aviation, this maneuver is called a go-around. Runways also use lighting systems to guide pilots during nighttime operations. The first 3 feet of the runway are equipped with special lights that help pilots determine whether they're landing within the correct touchdown zone. The lights that appear green when viewed from the approach side indicate that this is the proper touchdown area. However, when viewed from the opposite direction, those very same lights appear red. That tells pilots approaching from the other end that they're looking at the end of the runway. Along both edges of the runway, you'll find white lights. But during the final 2,000 feet, those edge lights change to yellow, warning pilots that the runway is about to end. The centerline lighting also changes as the aircraft nears the end. Throughout the final 3,000 feet, the centerline lights alternate between red and white, 1 white, then 1 red. But during the final 1,000 feet, every centerline light becomes solid red. This provides an unmistakable warning that the runway is almost over. But what happens if the weather is bad or dense fog completely hides all of these runway markings? How do pilots land then? In today's modern aviation era, many international airports are equipped with an ILS, or Instrument Landing System. Using highly precise radio signals, this system continuously tells the aircraft's autopilot exactly how far it is from the runway centerline, what glide slope it should follow, and where it should touch down. The next time you look out the window of an airplane, you'll probably understand the language of runway numbers and runway markings much better than before. Hopefully, you'll also give this Nova Reports video plenty of likes and shares. Thank you so much for all of your wonderful comments and support. I'll see you in the next amazing video.